All right, so here is the start of section 7.4 video. Now we're going to start with a little warm-up just to get our brains going. So I want you to go through and answer the questions for 1 through 6, and then we'll go over them. All right, so let's go over these. So on this first diagram, it covers angles 1, 2, and 3. Now notice that this is a parallelogram because it showed you that opposite sides are congruent, or opposite sides are parallel, I'm sorry. So what we have is that this angle here and this angle here are congruent because they're alternate interior angles. And then these two marked in red are also congruent because they're alternate interior angles. Okay, well, the parallelogram tells us that opposite angles are congruent, so angle 3 is 90 degrees. Okay, and then I can use that to find angle 1 because I know that if I add the angles here, they have to equal 180. So that's my work here. I get angle 1 is 51 degrees, and then angle 2 is congruent to the 39 degrees. All right, if I look over here, kind of the same ordeal. These green ones here are alternate interior angles. These yellow ones are alternate interior angles, and then you have 125. What I had to do here is I knew that 125 plus 22, so this is, probably should have labeled this is 22, plus this angle here is 180, so I used this triangle right here, added them up to equal 180, and I got angle 4 is 33, and then 5 is congruent to 4, and then 6, obviously, I got first, it was congruent to the 22 degrees. All right, so in this section, we are going to look at some more specialized parallelograms, okay? Specifically the rhombus, the rectangle, and the square. Now, it's very important that you know the exact definitions of these, okay? I know you kind of generally know what they are, and you're probably rolling your eyes like, yeah, I already know these, but seriously, pay attention to the definitions because it will help you a lot. Okay, so a rhombus is a parallelogram with 4 congruent sides. So because a rhombus is a parallelogram, that means all properties of a parallelogram will also be true for the rhombus as well. Okay, plus it has the added property if it has 4 congruent sides. Okay, a rectangle, it's a parallelogram, so of course all properties of a parallelogram would hold true for the rectangles too. And this one has 4 right angles. Okay, the square is also a parallelogram, so it has the properties of all the properties of a parallelogram, and it has 4 congruent sides and 4 congruent angles. So I want you to think about this. Is a square a special rectangle? Okay, is a square a rectangle? By definition, is a square a rectangle? Well, yes, it is, because a rectangle is a parallelogram. Well, square is a parallelogram, and it has 4 right angles. A square has 4 right angles. So the answer to this question is yes. Okay, now I'm going to ask you, is a rectangle a square? Is a rectangle a square? No, it's not, because a square has 4 congruent sides and 4 right angles. A rectangle doesn't have 4 congruent sides, and therefore a rectangle is not a square. So it goes one way and not the other. Guys, here's some corollaries, and I'm not quite sure why your book does it the way they do, but these corollaries are kind of just retelling the definition of each one of these. So the rhombus corollary just says a quadrilateral is a rhombus if and only if it has 4 congruent sides. That's what makes it a rhombus. Okay. The rectangle corollary, a quadrilateral is a rectangle if and only if it has 4 right angles. And then the square corollary, it is a square if and only if it is a rhombus and a rectangle. So it has 4 congruent sides and 4 congruent angles. All right, let's look at example 1. It says for any rhombus QRST. Now, guys, I'm a very visual person, so I'm just going to draw a rhombus QRST. And remember, a rhombus has all congruent sides. Okay, so now I have a visual to go with my questions. Okay, so decide whether the statement is always, sometimes, or never true. Draw a diagram and explain your reasoning. Okay, we had to draw a diagram anyways. All right, so angle Q is congruent to angle S. Here's angle Q, here's angle S. So is that always, sometimes, or never true? Okay, this would always be true. And the reason it's always true is because a rhombus is a parallelogram. And a parallelogram, the opposite angles are always congruent. And because a rhombus is a parallelogram, all properties of a parallelogram hold true for a rhombus. Okay, let's look at B now. It says angle Q is congruent to angle R. Always, sometimes, or never. Okay, this would be sometimes. Remember that in a parallelogram, these angles are supplementary. So the only way that these two can be congruent and supplementary is if they were both 90. And if this were 90, then this would be a square. Okay, if these two are 90 degrees, well, opposite angles are congruent, so that'd be 90. That'd be 90. Now we have 4 congruent sides and 4 right angles. We would have a square. All right, let's look at C. And this is different. It needs a different diagram. So it says for any square JKLM. Okay, it's a square, so it has all right angles and all congruent sides. I know it doesn't look like it. Always, sometimes, or never true that JK is perpendicular to LM. Okay, now this does 2 things. 1, do you know what perpendicular is? And 2, do you draw a picture to look at it to see? Okay, well, this is never. Because they're opposite sides, and therefore they're parallel. Parallel lines never intersect, nevertheless intersect at a 90-degree angle. All right, I want you to go ahead and do D on your own, and then we'll go over it. I highly encourage you to draw a figure. All right, I've gone ahead and drawn a rectangle, and I've highlighted FG and GH, which were the 2 there in question. So is it always, sometimes, or never true that FG, which is right here highlighted in purple, and GH, which is highlighted in blue, are congruent? Explain your reasoning. Well, in a rectangle, usually they're not, but they can be. Okay, if this is congruent to this, we know this is a parallelogram because opposite angles are congruent, both pairs. So EF would have to be congruent to GH, and EH would have to be congruent to FH. So this would be sometimes, and the only time it would be when this is a square. And remember, a square is a rectangle is not always a square. All right, let's look at this quadrilateral here. It says, classify the special quadrilateral and explain your reasoning. All right, so we know it's a quadrilateral and all 4 sides are congruent. Okay, well, that tells me both pairs of opposite sides are congruent, so we know it's a parallelogram to start with. Okay, well, if it's a parallelogram and all 4 sides are congruent, that means it's a rhombus. Okay, now the question becomes, is it also a square? And I'm going to put a question here because we don't know. So the difference is between a rhombus and a square is this has 4 90-degree angles, this does not have four 90-degree angles. Or I guess it can, but this is what makes it a special rhombus. Well, clearly, this isn't a 90-degree angle, so this goes away. So all we have is a rhombus. All right, so when we're talking about a rhombus, the rhombus has two properties that really go along with it. So we have a property of a diagonal. So the rhombus diagonals theorem basically tells us that if a parallelogram is a rhombus, if and only if its diagonals are perpendicular. Okay, so these are perpendicular. Now notice that a rhombus is a parallelogram, so the diagonals, because it's a parallelogram, the diagonals bisect each other. But this theorem tells us that they're also perpendicular. Okay, so I can conclude that in a rhombus, the diagonals are perpendicular bisectors, they do both, of each other. Now guys, the hardest part about this chapter is to keep all of these properties in line with each shape. So try to do that as much as you can. That way you're not cramming the night before. All right, so that's this theorem. Now the next theorem we have is the rhombus opposite angles theorem. And it just says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Okay, so what I mean is the diagonal comes through here, which makes this angle here and this angle here the same. This angle here the same, and this angle here the same. Okay, and then the same thing for these two opposite angles as well. All right, so using those two theorems and the properties you already know about parallelogram and rhombuses, I want you to go and try to do A, B, and C on your own, and then we'll go over each one of these. All right, let's look at part A first. It says find the measure of the number angles in ABCD, and we're given that this is a rhombus. Right there. So number one should be the easiest. The diagonals are perpendicular bisectors. Well, perpendicular means that they cross at a 90-degree angle. All right, now let's look at this. So if this is 61 degrees, guys, this here is 61 degrees. Okay, which means this whole angle here is 122 degrees. If that whole angle is 122, well guys, properties of a parallelogram, this has to be 122. And because it's a rhombus, this is cut into two congruent parts, which is 61 and 61. So angle 2, 61 degrees, angle 3 is 61 degrees. Okay, now to get angle 4, I want to look at this triangle here. Okay, I know all three of these angles have to add up to 180. So angle 3 is 61, angle 1 is 90, and I don't know angle 4, I'm just going to call it x equals 180. Okay, so 151 plus x equals 180 minus 151, I get x equals 29. So angle 4 is 29 degrees. All right, so if angle 4 is 29 degrees, that means this here has to be 29 degrees as well. Okay, which means this whole thing is 29 plus 29, which is 58 degrees. And if this whole thing is 58 degrees, properties of a parallelogram, this whole thing is 58 degrees as well. Okay, so ADC, where's ADC? ADC right here, we just said this is 58 degrees. And BCD, this is 122 degrees. And notice, if you add these, they add to 180 because this is a parallelogram and consecutive angles are supplementary. All right, if I look at C, this is 118 degrees here. And I know consecutive angles are supplementary, which means this has to be 62, this has to be 62. Properties of a rhombus, these bisect, so all of them are 31 degrees.